Lastly, question 10. Actually, unusually, question 10 contains some of the sort of more straightforward content that you might expect normally to see at the beginning of the exam paper, like the difference between a compound and a mixture. There are 2 marks here, so there's 2 different things that were expected. The first thing is to say that a compound, which most people identified, is bonded or combined, is chemically combined, or you might have said bonded, which is absolutely fine. But then the second bit that very few people got was in a fixed ratio. Okay, the point is for any compound, you can write down a formula, okay, so like CH4, H2O, etc. Those are compounds. You have to be able to identify the relative number of hydrogens and oxygens in water, or the relative number of carbons and hydrogens in methane. A mixture could just be any random number of the things that you're mixing together. Mixed together, it'll still be a mixture, but a compound has a defined ratio of the elements that are combined. Then identifying that hydrochloric acid always produces a chloride was the next bit, which lots of people got. Magnesium is quite a reactive metal, so if there was magnesium here at the surface of the coin, we'd expect the magnesium to fizz, okay, which is really all you had to say. So it was just that Mg is quite reactive, and therefore you'd expect Mg would fizz or react violently, or words to that effect. Then chromatography works by taking a solution of a mixture. In this case, the coin solution was originally spotted here, where I've made a blue mark for the coin solution. But then, as the solvent has soaked up the filter paper, it's disappeared from its original point, and it's been separated out into these 2 components. One spot has moved really quickly up the filter paper, the other spot has moved much more slowly. You want to make a small spot at the baseline, okay, so that if they were really wide, if they were huge spots like this, there's a danger that as they soak up the filter paper, they're going to kind of merge and make a mess in the middle, okay? So it's just to prevent the spots overlapping or merging. The spot containing Fe2+, if we look at it, stays on the baseline here because it hasn't moved at all because it's not soluble in the solvent. In this case, I think the solvent's probably water, but okay, right. Why does the Fe2+ stay on the baseline? It must just be insoluble in the solvent. The spots only move up the filter paper because the solvent is dragging them up, the liquid is making them soak up the paper. But if the spots aren't soluble in the solvent that you're using, they're not going to move at all. So it's just that. In this case, the Fe2+ is insoluble in whatever the solvent is that's being used for the chromatography in this case. Then the whole point of the experiment really is to show what do these 2 spots here represent, if we just call them A and B. Spot B, okay, if we look at the top one first, must be caused by copper ions because the copper ions travel the same distance as that part of the coin solution represented by B. The part of the coin solution represented by A matches up with the nickel 2+ ion, so the original coin must contain nickel and copper. And that's it.